other animals began in earnest over 150 years ago. When Charles Darwin wrote The Origin of Species, he argued that every major group of animals evolved from a pre-existing one. He predicted that we would find fossils with features that linked one major group to another. In fact, he staked his theory of evolution on the existence of these intermediates. But no fossils were yet known that reveal these transitions. Then, just 2 years later, a marvelous creature was unearthed from a limestone quarry in Germany. The 150-million-year-old fossil named Archaeopteryx rocked the scientific world. This Archaeopteryx fossil is truly remarkable. It preserves in fine detail feathers along the wing, just like those we see in living birds, and feathers along the tail. But the bony features tell a very different story. If we look closely, we'll see teeth in the jaw, tiny claws preserved in the hand, and a long bony tail, lacking in living birds, but present in things we think of as traditionally reptilian. For Darwin, it must have been an incredible vindication. He predicted that we would find forms like these. Archaeopteryx pointed to a close link between birds and reptiles. But which group of reptiles? Flying pterosaurs have been discovered with light, hollow bones, but their wings are constructed very differently than the wings of Archaeopteryx and birds. Here is a tiny pterosaur, and if we take a closer look at its arm, we'll make out 3 small digits, and a 4th, which is really, really long. The membrane of a pterosaur wing attaches to this 4th digit and along its body and hind limb. In contrast, the wings of Archaeopteryx and birds have only 3 digits, and their feathers attach individually along their arm and hand bones. These differences tell us that pterosaurs and Archaeopteryx evolved flight independently. Archaeopteryx must have descended from different reptiles. Thomas Huxley, Darwin's champion, was astonished by Archaeopteryx's resemblance to a turkey-sized dinosaur called Compsognathus.